Mela, issa wasanna l-aħħar topic, at last, acids, bases and salts. Ħafna mill-affarijiet tiġa għanna idea tagħhom, per eżempju examples ta' acids, properties ta' acids, u ħajkun hemm ukoll xi affarijiet li ħanitalmu fuqhom f'din il-lezzjoni li huma ġodda. Dan it-topic qiegħed fuq page 130 tal-booklet. So, what are we going to be learning? Where are acids found? The element which is always found in acids, I think you already know, it's hydrogen. What happens to acids in water? What is the difference between a weak and strong acid and the type of reactions which acids can perform? Acids jaqgħu fil-klassifika ta' grupp ta' compounds li huma soluble. Allura, meta nirrappreżentawhom ġo equation, dejjem nużaw l-state symbol AQ. Dil-istampa turina tipi ta' ikel differenti u ħafna minn daw l-ikel li huma preżentati fuq din il-mejda għandhom xi tip ta' acid fihom. Jiġifieri, acids are not only found in laboratories, we also found acids in our kitchens. And for example, orange juice, oranges, lemons, apples and limes contain citric acid. Per eżempju, il-ħalib għandu lactic acid. So it's important to appreciate the fact that acids can be naturally found. U acids nistgħu nsibuhom ġol-arja, anka ġo ġisimna, fid-dar, fil-affarijiet li nixtru, fil-ħamrija wkoll tista' tispiċċa aċiduża. U li ħankunu qed nagħmlu issa ħaniddiskutuhom. Daw il-places fejn nistgħu nsibu l-acids ħaniddiskutuhom wieħed. L-aċtu jista' jispiċċa ġo x-xita minħabba li ikun hemm acids li jinsabu ġol-arja. Konna semmejna fit-topic ta' atmosfer li jistgħu jiġu released pollutants mill-karozzi, per eżempju, mill-chimneys, all these human activities can lead to pollutants being released into the air. These pollutants can be sulfur dioxide, for example, or carbon dioxide, and these being acidic oxides, konna rajna li they react with water to produce acid. Fil-fatt, din il-general equation tiġa nafu bija. Okay? U acid rain konna rajna għandha ħafna repercussions. Per eżempju, il-weraq tas-siġar ma jibqawx green, they turn yellow. It kills aquatic animals. It makes a lot of damage. U daw kienu ħafna minn problems li rajna. Acid ukoll jista' jinsab in our body, fl-stomach precisely, u l-acid li jinsab fl-stomach huwa hydrochloric acid. L-aċtu fl-istonku għandu funzjoni li joqtol any germs which we might have ingested through our food. Issa fil-fatt hawn min li bagħti b'kundizzjoni ta' indigestion where your stomach produces a lot excess of acid. And people who suffer from this condition might end up taking tablets of which contain alkali to neutralize the excess acid. Acids ukoll nistgħu nsibuhom fil-kċina tagħna, bħal pereżempju fil-vinegar insibu ethanoic acid. In lemons and oranges we find a natural acid which is citric acid, and in fizzy drinks we find also carbonic acid. Acid may end up also in soil if there is an area which is a polluted area where there is acid rain. Even the soil can end up acidic. and the pH of the soil can end up below 7. F'areas li jkunu affettwati minn acid rain, allura jkollhom din l-acidic soil, mbagħad il-farmers ikunu jridu li jittrattaw is-soil with an alkali. Ħanaraw iktar qudiem fil-lesson x'ħajkunu l-alkalis li l-farmers jitfgħu fuq is-soil. Mela, sissa dak kien introduction. Issa ħanibdew with the important points. Properties of acids. Mela, acids usually have a sour taste, and this reminds us of the taste of lemons, per eżempju. Acids are all soluble in water. Highlight this point, please, and next to it write that usually the state symbol of acids is AQ because they are soluble in water. Aqueous tfisser. Acids are often corrosive. Fil-fatt, il-symbol assoċjata ma' corrosive hija dawk id-drops niżlin u mbagħad dawk iż-żewġ idej. Jiġifieri, if it makes contact with the skin, you will feel an irritation. Acids turn blue, litmus red. Litmus huwa tip ta' indicator li jurina jekk għandna acid jew alkali preżenti. Fil-każ ta' meta jkun preżenti ma' acid, jiġi minn blue jinbidel ġo aħmar. Acids are neutralized by bases, fil-fatt din konna tallimna fuqha fit-topic ta' oxides. Acids react with metals to release hydrogen, ġdida ma konniex nafu biha. U acids react with carbonates to form carbon dioxide. Highlight point 2, 4, 5 and 6. Now, making acids, page 131. So, acids nistgħu niffurmawhom meta jkollna reaction ta' acidic oxide mal-ilma. Di diġà tkellimna fuqha fit-topic ta' oxygen. Jew inkella meta acid ikun magħmul minn two elements bħal hydrochloric acid, we can produce acids by reacting the elements it is made from. Okay? Write the general equation underneath the reaction of carbon dioxide, please. Issa. Hawnhekk f'din it-table ta' page 131 għandna most of the common acids. L-acids li huma in red, you need to know them, okay? The ones in red only are important. And you need to know the name of these acids, the formula, if they are weak or strong, and where they are found. So, if they are weak or strong, they are important. If they are weak, the acids will have a pH which is close to 7, bħal per eżempju pH 5. Jekk l-acid ikun strong, ikollu pH li iktar tkun close ta' 1. So the smaller the pH, the stronger the acid, the larger the pH, the weaker the acid. Okay? Mela, pause the lesson, please, and fill in the table. Now, x'qed ninnutaw fuq acids? Acids kollha għandhom hydrogen fil-formula tagħhom. Mela, biex ikonna chemical li jaġixxi bħala acid, irrid ikollu hydrogen fil-formula tiegħu. Highlight the sentence underneath the table on page 131. An acid is a substance that releases hydrogen ions when dissolved in water. Okay, mela highlight this sentence, please. Issa, fuq page 131 għandkom table li hija iktar concise tal-most important acids. Okay? This table is very important. Tiġadi konna l-tqajna magħha fit-topic ta' covalent bonding fejn konna rajna examples ta' acids. Okay? So di suppost tiġa għandkom idea tagħha. Now, an acid jista' jiġi rappreżentat in general by the formula HA. In general, ġifir dal-acid HA mhux vera jeżisti, imma jirrappreżenta il-format ta' il-formulae ta' ħafna acids. U l-formulae ta' ħafna acids ġeneralment tkun tibda bil-hydrogen, bekk H, except għal-ethanoic acid, u t-tieni parti lej tirrappreżenta the rest of the molecule li ġeneralment tkun a compound ion, bħal per eżempju carbonate, bħal per eżempju sulfate, bħal per eżempju nitrate. So HA, I'm going to repeat, mhux vera teżisti, it's a general formula of acids. And it shows that most of the formulae of acids start with hydrogen, and the rest of the molecule, A, is the rest of the molecule. Now, something special happens to acids when they are in water. A process called ionization happens to acids when they are in water. And when an acid is in water, importanti in water only, jiġifieri if it is in another solvent, this does not happen. Ionization happens when they are in water. And for example, over here I have an acid, a fictitious acid, AB. And when it is in water, it ionizes. X'jiġifieri ionizes? Jiġifieri, it splits up into a cation and an anion. Cation infakkarkom li hija plus charge u anion hija minus. U dan jiġri lil kull acid in water. They split up. So, ionization refers to the splitting up of a molecule, tal-acid, which usually occurs in water. Din id-definition, please, ħatikdbuha bil-kulur in the middle of page 132. U dan jiġri minħabba li din il-bond tinkiser ta' bej A u B. Issa, ħanapplikawa iktar ċara għal acids. Meta acids jagħmlu ionization, dejjem jisseparaw ġo H plus and a negative anion. And over here in this picture, we're seeing the ionization, the splitting up of HCl. Mela, this happens in water, and in water, the covalent bond between the hydrogen and the chlorine breaks down. Kif tinkiser? Tinkiser billi daw il-par electrons, this pair of electrons, go towards the chlorine. And the hydrogen ends up without electrons, fil-fat bekk hija vojta, din l-electron shell biex nispjegalkom għamilta hekk, u daw iż-żewġ electrons imorru għand il-chlorine. Allura il-chlorine jiġi negative għax għandu extra electrons. U l-hydrogen jiġi plus għax għandu missing electrons. And this happens in all acids when they are placed in water. Iġifieri, they separate into H plus and a negative anion, which is also always different according to what the acid is. U di l-ionization tista' tiġi rappresentata ġo equation. Okay? Mela HCl għamilt l-state symbol AQ għax jgħat in water, and I'm showing through this equation that it is splitting up into an H plus and a Cl minus. U H plusism waħda fil-fat minix qed nagħmel coefficient u Cl minus hemm wieħed ukoll fil-fat minix qed nagħmel coefficient ukoll. Issa, fuq page 132 ħanamlu equations oħrajn bli juru ionization, din id-darba ta' acids differenti. Always following this pattern. So, when an acid is in water, għawek għaw general equation li jatturi l-ionization, dejjem jinqasam ġo H plus u A minus. U A minus di hija l-acid, the other part of the molecule, acid radical, għaw min jgħidilha wkoll, u dejjem tkun differenti skont l-acid xi jkun. Per eżempju, di kienet ta' hydrochloric acid, issa ħanaraw example ieħor. Din id-darba ta' nitric acid. So for nitric acid, the splitting up will occur over here, okay? Allura 1H plus and 1 nitrate, okay? Importanti please li meta ħatamlu l-ionization dejjem tridu tinkludu iċ-charges. Hydrogen dejjem plus sumbat NO3 titfittex mill-table tal-compound ions. Din ir-reaction ħad kompluha fuq page 132. Okay, there are the fill in the blanks. The next acid is sulfuric acid. Mela, sulfuric acid l-istess ħajamel ionization skont dan il-pattern. Pero, sulfuric acid għandu 2 hydrogens, allura ħaj jifforma 2H pluses. Iġifiri issa għanna bżon coefficient. Sulfate għandi waħda. Allura mhux ħanamel coefficient quddiem is-sulfate. Kompluti l-equation fuq page 132. Now, the last acid is phosphoric acid. Again, it does ionization following this pattern, but there are 3 hydrogens, so 3H plus and 1 phosphate. Fill in this equation on page 132. Now, it's important when doing ionization reactions that the total positive charge for the hydrogen ions must add up to the total negative charge. X'jiġifieri di? Jiġifieri, hawnhekk hawn 3 plus 3. U phosphate kombinazzjoni wkoll għandha -3. They must be equal and opposite, the positive and the negative always. Boom. Now, we're going to move on. Now we're going to discuss the difference between strong and weak acids. Mela, strong acid immarkajna l-ewwel fit-table hemm eżempji bħal sulfuric acid, bħal hydrochloric acid, nitric acid. Okay? U daw per eżempju is-sulfuric acid insibuh fil-batteries, fil-fatt meta tħalli xi appliance per eżempju bil-batteries fiha jista' jkollok instances fejn dak l-acid it escapes and it corrodes the outside of the battery and even the point of contact where the acid touches the appliance. Insibu wkoll strong acid, il-hydrochloric acid li jinsab fl-istonku. Issa, acids mhumiex dejjem għax xi kultant l-istudenti dejjem jassoċjawhom li huma dangerous, però aħna nużaw il-weak acids fil-kċina tagħna, pereżempju fil-vinegar, fil-frott, insibuhom, even some face creams are slightly acidic, pereżempju jkollhom pH ta' 5.5. Id-differenza bejn strong u weak acid hija li strong acid in water they release a huge number of H pluses. Okay? DH pluses are responsible for making the acid very strong. The number of H pluses. The more H pluses there will be, the stronger the acid is. Weak acids, on the other hand, are those which, when in water, they release a small number of H plus ions. Okay? Għalfejn, minħabba li strong acids jagħmel complete ionization. Ħanaraw kif. Jiġifieri daw in water kull molecule ħadd issepara ġo H plus u l-anion. Okay? Imma weak acid percentaġġ żgħir tal-molecules tal-acid ħajamlu ionization. Allura jispiċċaw jipproduċu ammont żgħir ta' H pluses. Mela, ħanibdew ħanikkumparawhom ma' xulxin. Mela, meta jkolli strong acid, ħajjiġri hekk. In water, all right, all the molecules will split up, will ionize. Right, fil-fatta hawnhekk qed naraw the white dots and the black dots, all of them have separated. Allura, ħajkun hemm a huge number of H plus ions. Peress li hemm ħafna H plus ions, il-pH ta' dak l-acid ħatkun ix-xaqleb lejn il-1. Per eżempju, pH 1, pH 2. Bħal fil-każ li jiġri fil-sulfuric acid, fil-hydrochloric acid ukoll. Issa, it-tieni sitwazzjoni hija meta għandi weak acid. Jekk tikkumparaw the first beaker with the second beaker, we're seeing that some of the molecules are still joined up. Jiġifieri, hemmhekk kien hemm partial ionization, għax mhux il-molecules kollha isseparaw. Right? Allura ma tantx hemm H pluses. Allura dak l-acid ħajkun a weak acid. Examples ta' weak acids insibu ethanoic acid li jinsab fil-vinegar, insibu carbonic acid li jinsab f'acid rain. Allura l-pH ħatkun closer to 7, per eżempju pH 5, per eżempju pH 6. Now, how do we represent the ionization of strong acid and weak acid? For the strong acid, bħala ionization, nuru a one-way arrow. For the ionization of a weak acid, we use a reversible arrow. Okay? U tin hija li l-eżampju li konna nitkellmu fuq qabel ta' hydrochloric acid, għax huwa strong acid nuża a one-way arrow, and then in order to represent the ionization of a weak acid, I have to use a reversible arrow. Issa, daw ta'kom tal-weak acids edin fuq page 133 li għandkom please l-arrow mhux edha eżatti, għax jiena ma stajtx nagħmilha once while I was typing the booklet. Please aqtaw l-arrows ta'kom u għamluhom eżatt kif qegħdin hawnhekk. Have a row to the right and have a row to the left. Now, mela, ta' carbonic acid, l-ionization, please, taħħa tridu tlestuha, għamlu fill in the blank u poġġu carbonate fija. Issa, ta' ethanoic acid hija ftit partikolari. Ethanoic acid, when it performs ionization, it loses this hydrogen only, the last hydrogen. Highlight this last hydrogen. Ionization will take place between the CH3COO over here and this hydrogen. Allura, meta jagħmel ionization, ħajifforma ethanoate, CH3COO minus, and H plus. So fill in the blanks and arrange the arrows and highlight the last hydrogen of ethanoic acid. Issa importanti please li nkunu ċari f'moħħna li acids jipproduċu H pluses if they are in water. So if they are in any other solvent or not in water, they can't act as acid because no H pluses are present. Issa, basicity, kelma ġdida. Basicity tfisser tirreferi għall-ammont ta' H pluses li jistaw jipproduċu acids in water. U for example, hydrochloric acid, when it performs ionization, it can release 1 H plus. Allura, dak l-acid jista' jitqies bħala monobasic. Ma ninsewx, mono tfisser 1. Monobasic ġifiri it releases 1H+. Fill in monobasic, please, in the blank. Issa, if we take a look at sulfuric acid has 2 hydrogens. It can release 2H+. Okay? Mela, is-sentenza tkomplu għajek. 1 molecule of H2SO4 produces 2 hydrogen ions and therefore is dibasic. Phosphoric acid, H3PO4 is tribasic because it releases 3 hydrogen ions. Mela, mill-parti ta' acids l-estejna, issa ħammorru għal-parti oħra, bases. Base tfisser a chemical which reacts with an acid to form salt and water. Iġifiri, chemical li jista' jinneutralizza acid. U bases jistaw ikunu jew methyl oxides, jew methyl hydroxides, jew methyl carbonates, jew hydrogen carbonates, jew ammonia. Daw il-families ta' compounds jistaw kollha jirreaktjaw ma' acids. Now, the solubility of bases, mhux daqshekk importanti di. Mela, methyl oxides nistaw insibu ta' group 1 u ta' group 2 huma kollha soluble. Il-bqija, il-methyl oxides kollha huma kollha insoluble. Methyl hydroxides ta' group 1 u 2 in general huma soluble u l-bqija huma insoluble. All right? This part is not important. Mark it not important, please. Now, ħafna studenti jisaqsuni ma jisu jisibu li fil-kodba base u alkali jisa tirreferi għall-istess ħaġa. There is a small difference between the word alkali and the word base. An alkali is a methyl hydroxide. Which is when dissolves in water, it ionizes into the metal ion and OH-. And they are water soluble. Examples include sodium hydroxide, potassium hydroxide, etc. etc. Bases, xifisser? Bases jistaw jirreaktjaw ma' acids biex jagħmlu salt and water, jistaw ma jkunux soluble, ġifiri daw jistaw jkunu solid, u jistaw anka per eżempju jkunu methyl oxides, bħal copper oxide, magnesium oxide, okay? So the difference between a base and an alkali is that an alkali is soluble u base mhuwiex. Alkali huwa methyl hydroxide u base jista' jkun methyl oxide, okay? Copy this table on a sticky note and attach to the bottom of this page, please. Okay, mela di li kont qed ngħid l-ewwel, alkalis huma soluble u bases le. Mela, l-alkalis importanti li rridu nkunu nafu. All right? We're doing page 134 and 135. Sodium hydroxide li għandu common name jiġi referred to as caustic soda, daw ħanaraw ftit information fuqhom ta' potassium hydroxide, KOH, calcium hydroxide, CaOH2, and ammonia. These are the common alkalis which we need to know. There is also sodium oxide and potassium oxide, calcium oxide. Issa, kif għattilkom tajjeb, issa ħan niddiskutu ftit information fuqhom. Ħanibdew bl-ewwel wieħed. Daw irridu nkunu nafu il-chemical name tagħhom, il-common name ta' kif jirreferi għalihom xi ħadd li ma tantx jaf chemistry and a use for them. Okay? Issa fin-noti jista' jkun li insemmi iktar minn use waħda, intom tidu tkunu tafu waħda biss. Sodium hydroxide jiġi referred to as caustic soda, u dan l-iktar use importanti tiegħu huwa li it is used in oven cleaners. Fil-fatt jintuża fl-sgrassatore. It is an ingredient in sgrassatore. It is also used to make cement and to convert fat into soap. So that is some information about sodium hydroxide. I would try to remember il-fact li jintuża f'oven cleaners. Alright? Now, magnesium hydroxide, dan it is referred to as, the common name for it is milk of magnesia, and it is usually used to treat indigestion. Fil-fatt dan huwa wieħed mill-ingredients ta' tablets li jitrattaw to treat people which have excess acid in their stomach. Quicklime, il-chemical name tiegħu huwa calcium oxide, u l-common name huwa quicklime, u dan huwa il-base li jintuża mill-farmers biex jitratta soil li hija aċiduża. Sodium carbonate huwa wkoll base ieħor, il-common name tiegħu huwa washing soda, and it is used in cleaning as well, washing soda, per eżempju biex jagħmel il-ħwejjeġ iktar bojot. Properties of alkalis at the bottom of page 135. Bases normally have a bitter taste. Issa daw ibidlu il-red litmus to blue. Highlight this point, please. Bases feel soapy. Or they neutralize acids. Okay? And highlight this point as well. So you're going to highlight point 2 and 4. Issa, for page 136 għanna the most important alkalis which we need to know. You need to know their name, their formula, and if they are weak or strong, and where they are found. Naraw id-differenza bej strong alkalis u weak alkalis. Mela, strong alkali fl-ilma jagħmel complete ionization. Issa ta'kom please miktub when a strong base dissolves in water. Taw il-kelma base please u iktbu alkalis. Mela daw pratikament jagħmlu ionization b'mod simili għal tal-acids. L-acids kienu jagħmlu ionization billi jinqasmu ġo H+ u negative anion, imma il-strong alkalis jinqasmu billi jagħmlu OH- dejjem u mbagħad a positive cation. Okay? So this is how strong alkalis ionize. Strong alkalis għandhom pH viċin ħafna il-14, per eżempju pH 13, pH 12. Mela cross out this word, please, bases and write alkalis, and fill in the blanks on page 136. Weak alkalis, alright, l-istess jagħmlu ionization imma din id-darba hija partial. Irranġaw ir-reversible arrow, please, u għamluha kif għamilta jiena. Okay, issa. Basic oxides. Daw il-basic oxides tiġa konna rajna u tkellimna fuqhom fit-topic ta' oxygen, u daw għadna li jistaw jirreaktjaw ma' acid biex jagħmlu salt u water, u jistaw jirreaktjaw ma' l-ilma biex jagħmlu metal hydroxide, konna rajna. Then there were the amphoteric oxides, and these we said cannot are in the section, of metal oxides, and they cannot be basic oxides. We need to remember the amphoteric oxides by heart. Għawek għaw two examples minnom, zinc oxide u aluminium oxide, pero oħrajn tin oxide u lead oxide. U daw jistaw jinneutralizzaw kemm acid u kemm base. Issa, is-section ta' bases l-estejnija ħanibdew is-section ta' indicators. X'inhu l-rwol ta' indicator? Indicator jisu bħal indicator tal-karozza li juri jekk sejra left or right. Imma l-indicator tal-chemistry biex niftehmu jurik jekk għandek acid jew alkali jew inkella neutral. Different indicators show different colors. Some have a new color when neutral and some don't. There is another type of indicator, the universal indicator, which gives you an extra piece of information. According to the color it changes, according to the shade of color, it is able as well to give you the pH, ġifiri the strength of the acid or alkali you have. Mela, ħanibdew. L-ewwel wieħed litmus ġeneralment jiġi fil-forma ta' karta. Huwa red when present in an acid. Okay, ġifiri if it is blue it will change to red in an acid. If it is placed in a neutral solution, such as water, for example, red litmus will remain red and blue litmus will remain blue. In an alkali, litmus paper from red will change to blue. Methyl orange, red in acid, orange neutral, and in alkali yellow. Phenolphthalein, colorless in acid, very light pink in neutral and pink in alkali. Universal indicator, issa da fil-verità juri range kbira ta' kuluri, jien qed nieħu very strong acid and very strong alkali. In very strong acid huwa red, in neutral green u blue in alkali. Issa għodu attenti please, meta tagħmlu l-fill in the blanks ta' din it-table, il-neutral tiegħi qiegħda fin-nofs tagħkom il-kollim ta' neutral qiegħda fit-tarf, so għodu attenti il-kuluri li tikkupjawhom fil-kaxxi it-tajbin. Daw il-color changes li kont qed nispjega. Issa, ħanifukaw naqa' fuq universal indicator, page 137. Universal indicator jista' juri iktar minn 3 colors minħabba li huwa a mixture of indicators. U kif għattilkom tajjeb apparti l-kulur jagħtina idea ta' strength tal-acid jew l-alkali li jkollna minħabba il-pH value. Jekk ikonna pH value ta' 7, il-kulur jiġi aħdar u dak ifisser huwa neutral. Jekk il-pH value jiġi minn 0 sa 6.9, ifisser li s-solution tagħna hija aċiduża. U tista' tiġi u turi kuluri jew yellow, orange jew red. Jekk ikun alkali solution, il-pH value li ħajuri ikun minn 7.1 sa 14 u l-kuluri li juri ikunu iktar skuri, very dark green, blue and purple. These are examples of liquids which we make use at home and even bodily fluids, and they are classified according to their pH. Il-battery acid, per eżempju, sulfuric acid huwa very strong acid, għandu anka pH ta' 0. ċili anka tista' ssib pH scales li jmorru bil-negative numbers. Aħna ġermet neħduha minn 1 sa 14, ma hekk qiegħda minn 0 sa 14. The hydrochloric acid ukoll li jinsab fl-istonku tagħna huwa quite strong. U lemon juice and vinegar as well. Issa, fuq dir tikkummenta, urine as well is slightly acidic. Huwa pH 6. Fil-fatt, ġeneralment minn pereżempju jkollu sintomi ta' urine infection, l-ewwel ħaġa li jagħmel it-tabib huwa a pH test because an infection will change the pH of the urine, pereżempju jiġi iktar acidic. Dak nota żgħira. Li kont qed ngħid l-ewwel ara caustic soda, sodium hydroxide, which is found in sgrassator, it is a very strong alkali. Soapy water as well, milk of magnesia li kont ngħidilkom l-ewwel li jitratta l-acid indigestion. Okay? So this is interesting to read this table. Issa, fuq page 137 fil-qiegħ għandna li universal indicator jista' jinsab ġo tliet apparenzi differenti. Universal indicator di l-iktar komuni nużaw fil-forma ta' likwidu. Universal indicator jista' wkoll ikun fil-forma ta' paper u anka pH meter fejn inti jkollok probe li you insert it in your solution and then you attach it to a monitor and it will show you the pH value of that solution. Fill in the blanks on page 137. Now, salts diġà tkellimna ħafna fuqhom fit-topic ta' oxygen u anka ta' water. Salt jikkonsisti huwa prodott minn neutralization reaction. Nafu mill-lezzjonijiet ta' qabel li meta ngħidu salt fil-chemistry mhux dejjem nifhmu li huwa sodium chloride u jiġi iffurmat meta il-metal jieħu post il-hydrogen. Din is-sentenza please li jien qed nikteb bl-aħmar ħadd tiktbuha at the top of page 138. Huwa ionic allura jkollu properties ta' ionic compounds, per eżempju being solid. Now, Mela, we were saying that a salt is formed when the metal replaces the hydrogen of the acid, okay? U hawnhekk għandi neutralization reaction bej alkali u bej acid u biex niffurmaw is-salt qed naraw is-sodium li spiċċaħa post il-hydrogen. Allura s-salt ħajjiġi sodium chloride. So the first part of the salt comes from the alkali and the second part of the name of a salt comes from the acid. Mela jekk l-acid tiegħi kien hydrochloric acid għandu klorin, is-salt tiegħi ħajkollu klorin ukoll. Bekk ikun sodium chloride. U hawnhekk għandna xi nota li tista' tgħinna kif nistgħu ninnejmjaw salts. Mela, ġeneralment l-isem ta' acid jispiċċa ik, tneħħi il-IC part u żid ide jew 8 jekk għandu oxygen fih. Mela f'dan il-każ jekk hydrochloric acid tneħħi mela minflok hydro tpoġġi l-metil u minflok il-ik part tpoġġi ide, diment li m'hemmx oxygen ġo salt. That's just a side note. Issa, l-aħħar parti ħanispjegaha minn hawn. Mela, is-salts jiġu mill-parti mill-acid u parti mill-alkali. Il-tip ta' salt li kollok jiddependi mill-acid li tkun użajt fir-reaction. Jekk użajt nitric acid, HNO3, mela the H part is going to be removed and the metal is going to be inserted instead of the hydrogen. So ħajkun hemm metal u l-NO3 part. NO3 mill-compound ions jisimhom nitrate. So the type of salt which is going to be produced from nitric acid is going to be nitrate salts. Jekk ikolli sulfuric acid. Jekk ikolli sulfuric acid, H2SO4 mela l-hydrogens ħajitilqu minflok ħajidħol metal u jibqa' SO4. SO4 mill-compound ions jismu sulfate. So sulfate salts are going to be produced. Hydrochloric acid, HCl, jitlaq il-hydrogen jibqa' klorin, allura t-tip ta' salt ħajkun hemm huma chloride salts. Issa, fuq page 138 għandna table vojta u għandna l-ismijiet tal-acids, intom għandkom ukoll il-formulae. U t-tip ta' salts li ħajkunu qed jiffurmaw. Per eżempju, nitric acid, il-formula HNO3, mela jifforma nitrate. U għawek għazilt example jena, a random example. Sodium nitrate, mux bil-fors bis-sodium, tista' tagħmel metil ieħor, calcium nitrate per eżempju, barium nitrate, okay? So I decided to stick with sodium in the first three cases. Sulfuric acid jitilqu żewġ hydrogens, minn flok iż-żewġ hydrogens ħajidħol metil u jibqa' SO4, mela sulfate salts, right? Dawn spiegajt l-ewwel carbonic H2CO3 jitilqu żewġ hydrogens jidħol metil jibqa' CO3 allura carbonate salts. Alright? Issa l-aħħar waħda ethanoic acid tinsewx highlight the last hydrogen, l-aħħar hydrogen biss titlaq. CH3COO mit-table tal-compound ions jisima ethanoate. Allura ethanoate salts are going to be produced. Mela dik kienet it-table, pause the lesson and fill it in. Now, normal salts and acid salts. Mela, normal salt huwa meta jiġi format meta il-hydrogens kollha tal-acid ġew irreplacjati kompletament bil-metal ions. Per eżempju, hawnhekk għandi l-acid, hydrochloric acid, li għandu one hydrogen. Qed jirreaktja mal-alkali NaOH and the sodium replaced the only hydrogen there was. So, in the salt, no hydrogens are going to remain. Then, another example. Sulfuric acid is reacting with NaOH. This time, the acid contains two hydrogens. And two sodium ions are going to replace the two hydrogen ions. So, two sodiums replace two hydrogens. Maċ fadal hydrogen. Allura, f'daw iż-żewġ każijiet, sodium chloride u sodium sulfate huma examples ta' normal salts għax maċ fadallhom hydrogens. Okay? Mela, highlight the definition of a normal salt. Li tajt, a normal salt is formed when all the hydrogen atoms of the acid are replaced by metal atoms. Importanti dik il-kelma, all. Now, jista' jiġri dan il-każ issa fejn inti meta tkun qed tagħmel neutralization ma jkollokx biżżejjed alkali. Allura jiġri hekk. Minħabba li l-alkali huwa limitat f'di reaction, mela għandek KOH li jrid jirreaktja ma' sulfuric acid. L-acid f'dan il-każ għandu two hydrogens, imma because the amount of alkali is limited u jgħidlek fi questionnaire li huwa limitat, il-potassiums, alright, mhumiex ħajreplacejaw il-hydrogens kollha, hawnhekk hawn żewġ hydrogens, potassiums ħajreplacejaw waħda biss minn dawk il-hydrogens. Allura jiġi, mela, potassium wieħed replace one hydrogen, but one hydrogen is going to remain over there. So KHSO4. And as we are seeing here, the salt still contains one of the hydrogens from the acid. So this is an acid salt because it still contains a hydrogen. So an acid salt is a salt where only some of the hydrogen atoms, f'dan il-każ nofshom ġew irreplacjati, have been replaced by the metal atom. U f'dan il-każ is-salt ħajkun jismu potassium hydrogen sulfate. Issa. Tajjeb, issa. U importanti please li tkunu tafu id-definition ta' acid salt li hija below the table. Okay? And this happens because the amount of alkali is limited. Issa fil-question biex tkun taf jekk inti ħatamel neutralization reaction fej il-hydrogens kollha jiġu replaceati jew inkella partial the amount of hydrogens being replaced, irid jgħidlek li jkun hemm limited amount of alkali. Jekk ma jgħidlekx ħatoħodha li l-hydrogens kollha ħajjiġu replaceati. Now, issa, x'tip ta' acids jistgħu jagħmlu acid salts? Acids li jistgħu jagħmlu acid salts huma dawk l-acids li għandhom iktar minn hydrogen waħda. So, monobasic acids, alright, those which have one hydrogen, cannot form acid salts. Acids which have two or more hydrogens, ġifiri the dibasic acid and the tribasic acids, yes, can form acid salts and even normal salts, obviously. Now, issa u hekk għandna table li tikkumpara il-acid salts ma' normal salt. L-ewwel kolonna qed titratta acid salt għax għatfadalli hydrogen ġol għatfadalli waħda mill-hydrogens tal-acid hawnhekk fis-salt. U t-tieni kolonna qed titratta normal salt. Now, if we look at the equation, right, the potassiums are replacing only one of the hydrogen. Fil-waqt li in-naħa l-oħra il-hydrogens kollha telqu u minflok hemm potassiums. So hawnhekk qed naraw normal salt. Il-pH ta' dan is-salt minħabba li għad għandu hydrogen hija below 7, that's why it's called acid salt. And the other one, because no hydrogens are present, hemmhekk il-pH ta' dak is-salt mbagħad tkun 7. pH għadnija in-name potassium hydrogen sulfate u l-ieħor potassium sulfate. Now, you have a table on page 139 where you have the name of the acids. Issa, fej il-name tal-acids ma tkomx il-formulae, please. Imlewhom mela fej sulfuric acid H2SO4, fej carbonic H2CO3 u fej phosphoric H3PO4. Mbagħad it-tip ħanimlew it-tip ta' acid salt li jistgħu jipproduċu. Mela, f'dan il-każ sulfuric acid jista' jkolli acid salt fej waħda mill-hydrogen biss tkun telqet u jkun għatfadal waħda. So ikollhom tispiċċaw hekk, ikollok il-metil u mbagħad HSO4. Allura hydrogen sulfate. U hawnhekk tajt xi examples, alright? Mhux bil-fors daw il-metals tistgħu tagħtu. Pereżempju, nista' nuża potassium hydrogen sulfate. Now, carbonic acid, il-formula H2CO3, mela jista' jkolli acid salt jekk waħda mill-hydrogens tibqa' hemm u l-oħra titlaq. Allura ħajkollhom hekk metil u HCO3. Allura daw it-tip ħajkun hydrogen carbonate and a specific example calcium hydrogen carbonate. Phosphoric acid has 3 hydrogens. If it forms an acid salt, it can form an acid salt if, for example, 2 hydrogens leave but 1 remains. Allura ħajkollhom HPO4 u jkunu jissejħu sodium hydrogen phosphate, per eżempju, a specific example. So fill in this table. Issa, fuq page 139, okay, għandna table li ħankunu qed insemmuha ħafna u anke ħanerġgħu nagħmluha di in form 4. Din it-table jgħidula the solubility rules. U tgħidli minu soluble u minu insoluble. Issa, jekk il-compounds tagħna ikunu soluble, nagħmluhom l-state symbol AQ. So near soluble, please, in brackets write AQ. If the compounds are insoluble, then their state symbol would be S in brackets. So write S in brackets, please. Now, the first rule, iġviri l-ewwel row. Din tajt li compounds li għandhom potassium, li għandhom sodium u li għandhom ammonium kollha huma soluble. And they have no exceptions. Write no exceptions in the box. Okay? Iġifiri, compound bħal potassium chloride, potassium bromide, sodium bromide, sodium chloride, ammonium fluoride, per eżempju. Compounds li għandhom daw it-tlieta preżenti, waħda minn daw it-tlieta ħajkunu soluble. Iġifiri, namlulhom state symbol AQ. And there are no exceptions. Issa, it-tieni row. All nitrates are soluble. Mela, every compound which has a nitrate present in it is soluble, and therefore you do the state symbol AQ. Mela, calcium nitrate huwa soluble. Sodium nitrate huwa soluble. Barium nitrate huwa soluble. Lead nitrate huwa soluble. Silver nitrate huwa soluble. Any nitrate is soluble without exceptions. Write no exceptions in the box, please. Now, third rule. Most chlorides are soluble. Din id-darba hemm exceptions. Mela, il-chlorides kollha li mhux qed insemmina, per eżempju, magnesium chloride, barium chloride, sodium chloride, calcium chloride, kollha huma soluble ħlief dawn it-tnejn biss. Iġifieri, ma' silver chloride meta jkun ġo symbol balanced equation, nagħmel l-state symbol S għax insoluble. Jekk ikolli lead chloride ġo equation, ħanamel S ukoll. Il-bqija kull chloride li jeżisti, kull chloride compound, ħanamel l state symbol ta' AQ. Fourth rule. Most sulfates are soluble. Okay? Mela, sodium sulfate, per eżempju, potassium sulfate, magnesium sulfate, copper sulfate, zinc sulfate, dawk kollha huma AQ. Ħlief dawn it-tlet sulfates li hawnhekk. Now, I am conscious that on your notes you have silver sulfate and SrO4. Cross them out. Dawk, they are very unstable or they are very rare compounds. Okay? Ħanibqgħu bil-compounds li huma l-iktar komuni. Iġifieri, jekk ikolli barium sulfate ġo equation ħanamillu S bħala state symbol, lead sulfate ħanamillu S bħala state symbol, calcium sulfate ħanamillu S. Imma copper sulfate huwa wieħed mill-exceptions le, mela mbagħad nagħmillu AQ. Il-ħames rule. Issa di bil-kontra. Ħafna mill-carbonates huma insoluble ħlief dawn it-tlieta. Sodium, potassium and ammonium carbonate. Il-bqija huma insoluble, so barium carbonate, magnesium carbonate, calcium carbonate, daw kollha S nagħmlhom fi state symbols, imma daw it-tlieta biss nagħmilhom AQ. Oxides, most of the oxides are insoluble, ħlief daw it-tlieta, sodium oxide, potassium oxide and calcium oxide. The last rule, mela, most hydroxides are insoluble, for example, magnesium hydroxide, calcium hydroxide, daw kollha insoluble, ħlief again daw it-tlieta ta' sodium hydroxide, potassium hydroxide and ammonium hydroxide. Issa, mela, daw ir-rules, is-solubility rules huma importanti imma l-iktar għal sen oħra nkunu qed nużawhom. All right? And the last page, this is reading information fej ħataraw xi uses ta' some common salts. Baking powder, per eżempju, huwa salt sodium hydrogen carbonate, huwa acid salt fil-fatt, and this is used in the kitchen when you're heating, for example, or making a cake, because it decomposes to produce carbon dioxide. Washing soda, sodium carbonate, il-common name da tiegħu tiġarajnieh, jintuża biex ineħħi l-ġebla mill-ilma, water softening jgħidulu process. Epsom salts konna rajnieh meta konna nagħmlu water of crystallization, magnesium sulfate, heptahydrate, hept tfisser 7, bath soaps, and plaster of Paris, calcium sulfate, huwa gypsum basically, u jintuża wkoll anke biex meta jkollok xi ksur. Okay, thank you and happy holidays.